Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smartyurl.it/Jedi. My advice on how to pass actuarial exams is at smartyurl.it/pass. This video channel is at smartyurl.it/pass actuarial exams. Here are the links to information about online seminars and study manuals for exams P, FM, IFM, and LTAM that I offer. I direct the Actuarial program at Illinois State University. You can find information about it at smartyurl.it/actuary. If you would like to offer a tax-deductible, at least to the extent allowed by law, donation to support our students, please go to smartyurl.it/help ISU actuary. Here's a problem for today for exam P. For a Poisson random variable n with mean lambda, find the limit as lambda goes to 0 of the expected value of n given that n is greater than or equal to 1. And here's the solution. So the probability function for this distribution, for the Poisson distribution, is of the form f sub n of n equals lambda to the nth over n factorial times e to the minus lambda for n equal to 0, 1, 2, and so on. And then the expected value of n, given that n is greater than or equal to 1, the limit of that expected value is the limit of the sum from n equal 1 to plus infinity of n times f sub n, given that n is greater than or equal to 1, of n given that n is greater than or equal to 1. That's a limit as lambda goes to 0 of the sum from n equal 1 to plus infinity of n times f sub n of n divided by probability that n is greater than or equal to 1. It's because of this conditional probability. Now, of course, we start with n equal to 1 because it's not possible for n to be equal to 0 given that the value of the random variable is greater than or equal to 1. So that's why we start with 1. And what is the probability that n is greater than or equal to 1? It's 1 minus the probability that it's equal to 0. So it's 1 minus f sub n of 0. So this becomes the limit as lambda goes to 0 of the sum from n equal 1 to plus infinity of n times f sub n of n divided by 1 minus f sub n of 0. Now, this expression 1 minus f sub n of 0 does not depend on n, so we can just factor out the 1 over that, and we get the limit as lambda goes to 0 of 1 over 1 minus f sub n of 0 of the sum from n equal to times the sum from n equal to 0 to plus infinity of n times f sub n of n. Now you may wonder, why is it from 0 this time where it was from 1 before, but of course it doesn't make any difference because when n is 0, n times f sub n of n is equal to 0 times whatever the probability of hitting 0 is, but it's 0. So we didn't add anything here, just wrote it this way, but once it's written this way, you can see that this expression, the sum from n equal to 0 to plus infinity of n times f sub n of n, well, that's exactly the expected value of n. So this becomes the limit as lambda goes to 0 of the expected value of n times 1 minus f sub n of 0. The expected value of a Poisson random variable with parameter lambda is lambda. And 1 minus f sub n of 0 is equal to 1 minus e to the minus lambda. So we're looking for the limit as lambda goes to 0 of lambda over 1 minus e to the minus lambda. Well, a natural thing to try would be to just plug in lambda equal to 0. The top would be 0, and the bottom would be 1 minus e to the 0, which is 1 minus 1. So the top and bottom go to 0 as lambda goes to 0. And therefore, we can use the L'Hopital's rule, and this is equal to the limit as lambda goes to 0 of what's the derivative of lambda with respect to lambda? It's 1. What's the derivative of 1 minus e to the minus lambda with respect to lambda? Well, the derivative of 1 is 0, and the derivative of minus e to the minus lambda is minus, from the minus that is in front of the exponential, times the derivative of the exponential is the exponential itself, so e to the minus lambda, but the derivative of minus lambda is negative 1, and minus minus makes it a plus. So this becomes the limit as lambda goes to 0 of 1 over e to the minus lambda. And as lambda goes to 0, e to the minus lambda goes to 1. Therefore, because of course e to the 0 is 1. So this is 1 over 1 in the limit, and that's equal to 1, and that's answer C. Please remember this is copyrighted material. The problem was written by me and the solution is mine. All rights reserved. Reproduction in whole or in part without express written permission from the author is strictly prohibited.